welcome back to J.B. Straubel to CERAWeek. J.B. was here in 2016 when he was the Chief Technology Officer of Tesla. He's an immensely creative and visionary engineer. One of the things, I mean, you can read all about him actually in the new map, but I love when he was at Stanford, he created a major in energy systems engineering, and he was the only student in that. But he described when he was here last time, the lunch in 2003, where he suggested to Elon Musk this idea of an electric car, stringing together, as you put it, thousands of lithium-ion batteries. And Musk later said, without that lunch, there may well have been no Tesla. But when you were here in 2016, there were still a lot of challenges. You were there 15 years, and last year, the Model Y was one of the top 20 selling cars in the US. And we see tonight, we'll hear from the CEO of Ford at dinner about the commitment of automakers to electric cars, which would have seemed impossible not so many years ago. Now he's the founder of a company called Redwood Materials, and it's the next stage, and it's a critical stage, the supply chain for EVs. So he's here as a miner, but he's not mining from the earth. He's mining from, I guess we'd really say, from waste. From old batteries and old cell phones and so forth. But maybe just to take a moment on electric cars before we turn to Redwood Materials. You're always interested in electric motors, but JB, I'm sure you've been asked this many times, did you ever think that it would have the impact that it has had?
Well, it definitely, I'd say, has surprised me and probably everyone in Tesla, how fast the market has changed and how fast things have grown. We always hoped and dreamed that would be the case. That was the mission from the beginning, was to change the entire industry and catalyze that change. But the speed at which it's happening all around the world is incredible.
Right. So it is so fast. What's your thought now about the fleets of the auto fleets of the future?
Well, I think now more than ever, it's clear that we're headed toward an electric future. Even 5-6 years ago, there was a lot of doubt of whether that was going to be the technology that would, make it to escape velocity. Now I think everyone's widely accepted that, and we're really in this stage of understanding how to do the transition and how quickly it can happen, and what all the OEMs will look like as they reinvent themselves.
Right, and so that's where Redwood Materials comes in. You founded it in 2017, which is 5 years ago now. Why?
Well, at Tesla, I had a front row seat, to looking at some of the challenges, I think a little ahead maybe of some others, that were coming to the entire electric vehicle industry at scale. And one of those, a really big one, was related to the raw materials in the supply chain for how we would make enough batteries, to transition all the world's cars to electric. So at Redwood Materials, we're very focused on that. Maybe it's not the most sexy problem, not the most immediate problem, but it's incredibly relevant, and I believe is what may limit or gate our ability to do that transition as fast as everyone wants.
Right. So I've heard or I've read that what really hit you was visiting a mine in Canada somewhere.
Well, we did visit a lot of different mines and nickel mines, lithium mines, et cetera. And I think seeing the scale and the immensity of the challenge that was sort of behind the scenes of what it took to make an electric car and how long it would take, to double, triple, go 10x the capacity of some of those facilities sort of struck me. And it wasn't just about building another vehicle factory or changing one vehicle factory from internal combustion to electric, but it's creating and scaling a huge tail of the supply chain that has never operated at that level of scale before. And we're still in the midst of understanding that, I would say.
Yeah, that's what's emerged, just in general, I think supply chains used to be something that supply chain managers talked about. Now it's something that prime ministers and presidents talk about. And it's particularly if you're going to change, what do we have, 1.4 billion cars in the world? Supply chains are pretty important, and of course, everybody's learned about the importance. So, then as you looked at the problem, how did you think it through?
Well, batteries are also very unique and fundamentally different, of course, than hydrocarbon as a pathway. The materials inside a battery are not consumed. So as I was thinking this through, and as many others had the same general ideas, I would say, but kind of an aha moment is realizing that the future state of this is not going to look anything like the mine, manufacture, dispose world. There's an incredible opportunity to start to envision a really closed loop system around all that.
Right. And so if you look at a battery today, how much of the cost is actually the metals?
It's a massive amount. Could be between 50 and 70% of the cost of a lithium-ion battery are in the strategic components, the critical materials that make it up. It's very much the minority is actually the assembly of the battery, even though that's where we see the gigafactories and a lot of complexity there, but it's the minority of the cost structure.
Right. So you kind of saw the need, and then how did you go about envisioning Redwood Materials?
Well, we've started working on battery recycling. It's a pretty mundane part of the supply chain, and a lot of people were really confused and scratching their head of why leave Tesla and go and focus on garbage. But to me, this
what was your answer?
Well, it's really, I think, trying to look at the future of knowing that that is going to be the majority of how all that material moves. And to me, it might seem like maybe it looks like or sounds like science fiction, but if you imagine several decades or into the middle of the century, the whole fleet's electric, at steady state, the recycling and reprocessing of those materials will be bigger than the entire mining industry today. And it doesn't exist. No one's invented it, the pathways don't exist, the business model doesn't exist. So that was what's so exciting to me.
Right, so
we can architect that.
Yeah, and so thinking, because that loop just was not there.
And it still is kind of lurching itself into creation. We're having to do a lot of invention of the different processes and equipment and even the business relationships to make that happen. It's a little bit, to me, like inventing a concept of a battery refinery.
Right.
The oil world, of course, has been very good at this for a century. But we have to take in old battery materials, scrap batteries of all different sorts, refine them and then remanufacture them into a whole slew of valuable products to feed the industry.
So what are your raw materials?
Well, today it is recycled feedstock. So we focus on batteries from cell phones.
I guess it's cell phones?
Cell phones, exactly. There's a huge amount of cobalt in cell phones. It's one of the biggest resources of cobalt in the world. But also batteries from EVs. So end-of-life electric vehicles, hybrid vehicles, and even production scrap. From the manufacturing process of a battery, you lose 10 to 15% perhaps of that material.
Oh, so the wastage. So it's like, I guess but obviously a mine is a very concentrated thing. Here, just the collection, how are you envisioning that?
The reverse logistics and collection is a big challenge, and these materials are also hazardous. They're flammable, they can catch fire, they have transportation problems. But the benefit is they're so dense in terms of their elemental concentration. So a mine, and several people have noted this at the conference, you're dealing with maybe 1% or tenths of a percent of the element you're after. And it's the vast majority is rock that you have to crush and move and transport and deal with. In a recycled stream, it might be 100 times more concentrated. We might be dealing with tens of percent of the elements of interest. So we can be much more efficient about how much mass we have to move and process.
Right. So today you were with some people who are miners. Not miners of miners of old batteries, but miners in the traditional sense. Were they a little shocked hearing what you were doing?
Well, I think people are still. Recycling, has a common association. I think people imagine what's in their kitchen and plastic bottles and whatnot. This is quite different, and what we're envisioning is linking the collection and reprocessing of those materials straight into manufacturing. Most mining companies, I think, haven't really thought this impacts them in a huge way yet, and it won't for a long, long time. We're in such a hyper-growth phase in this industry that we need a lot of mining and we need all the recycling we can possibly do. But I think it's going to be massively more relevant in the future as this fleet of EVs starts to reach steady state.
Right. So how do you go out and, how do you gather the materials? Because I know that one of the challenges always with biofuels is is the gathering of it, and the cost of bringing that all together?
Well, we have a whole team we're pulling together. We work with a number of different businesses and companies. We're starting to launch a collection, very proactive collection of consumer devices, things like cell phones. Also just scrap batteries from people's lives. There's an amazing number of these that have kind of proliferated into our life. Toothbrushes, lawnmowers, et cetera. They all contain these same critical metals. All of this is also building toward EVs being the dominant supply. But we're starting early, and it's really important, I believe, to solve these problems and set up the pathway ahead of time.
Right.
Because the scale of what's coming at end of life for EVs, it's the same as what we're making today.
Yeah.
So we have to basically build an unmanufacturing infrastructure of the same scale that we had to build to make them in the first place.
It's an unmanufacturing. So, at what point, I'm sure a number of people here have Teslas. You met one as you were coming in. At what point does the battery life come to an end?
Well, it's a subjective thing depending on what people's goal is for the car, but I think it's easily going to be 15 years in most cases.
Oh, that long? Yeah.
I believe so. I think people will probably keep the batteries in their cars for a long time and really extract as much utility as they can. I also think battery life will probably track with the vehicle life. And I personally think it's probably less likely that people will replace a new battery into an old car, just given how fast technology is changing and how much better a modern EV might be than a 15-year-old EV at that time.
And so, how do you collect cell phones?
Well, we do work with a whole slew of different companies. We have relationships with a few different electronics distributors and retailers. We're even beginning to accept direct recovery of people. We have people sending us things, cold out, that we haven't even asked for. It's
so
kind
you
of
have an address. People can send their old cell phones, right?
Well, I think it's a strange phenomenon where most people that I know have 3 or 4 cell phones in their drawer somewhere at their house because they don't really know what to do with them. There's data security risks. There's the concern of just where it might end up.
Yeah.
So it's easier to essentially stockpile it than it is to find a way to recycle it. That constitutes an incredible resource. Very strategic resource, and especially right now when we see how difficult it is to secure and import some of those same materials.
Right. So what scale are you at now?
Today we're processing on the order of 8 to 10 gigawatt hours a year of material. Oh. It's enough for hundreds of thousands of cars of EVs worth of battery material.
Oh, really?
And this is sort of just the tip of the iceberg, really. This is largely not EV material yet.
Right.
These are kind of all the other applications that need to be dealt with in a good way.
Right.
As EVs start, this unmanufacturing, industry and its linkage back to supply chain has to map exactly how fast we're growing EVs, maybe by a lag of, let's say, 10 to 15 years.
And who are your customers now? If you're producing that much, who are you selling it to?
We work directly with the mining industries. We also work directly with battery manufacturers. So these same materials can be used again in battery manufacturing. That's another characteristic that's not very intuitive. I think a lot of people imagine a circular economy that's kind of getting worse and worse every time.
Right, yeah.
You kind of have this in your vernacular that you don't want the recycled thing, because it's probably not quite as good as the new thing. Yeah. It's a little worse.
Yeah.
It's sort of a brown paper that wasn't very appealing. But metals are different. Metals actually get better every time you reprocess them through that loop because you're removing out a higher and higher percentage of impurities.
Oh.
It's sort of like you had a glass of water that you kept putting through a water filter.
Right.
And if you filter that water 5 or 6 times, each path through it's getting cleaner and cleaner.
Right.
This is what happens roughly with metals.
Right. So in terms of the technology, was that technology out there and you could sort of on the shelf and get it, or did you have to bring a set of expertise together to identify the technologies for this?
We're still bringing it together even. It's surprisingly difficult. The manufacturing of the materials inside of a battery, there's a reason it's so expensive. And
Right.
the metals are one part of it, just the metal value, but the processing is very complicated. So this industry has not existed much in the Western world, chemical engineering expertise outside of the petroleum industry, but metallurgy and the metallurgical processing is largely moved overseas.
Oh.
So we are assembling that team. We're growing a lot of experts in electrochemistry, chemical engineering, metallurgy, and also automation. Because essentially we're building a gigantic factory and processing facility.
Right. So I know that from our previous conversation that you'd always been interested in electric motors since you were a kid. Are you having to learn a new set of technologies and a new science?
Well, it's definitely expanding deep into chemistry. I mean, I've really enjoyed that for a very long time, and to me, this is all kind of an extension of batteries.
Right.
Batteries are becoming, a core part of the sustainability revolution.
Right.
Whether it's for cars or trucks or airplanes in the future or the grid. So to me, it's just really a deep understanding of our whole team, for how batteries work, how their supply chain works, where the value chain exists. So it's building, but I'd say growing and deeper in some areas than we did even at Tesla.
So what are the expertise that you need to bring into this?
Well, it is automation. That's a really key one. But chemical engineering and plant design, these are things that, again, have not existed in the Western world all that much. Yeah. Asia has seen this as strategic, China especially, for a very long time. And, I think, this is something where we can't, I would say, really tolerate transitioning the entire fleet of transportation to EVs, but not having a supply chain for it.
Yeah.
I just don't see that being palatable. So one way or the other, we have to figure out how to bring the supply chain, to create it, to build it here. And we have to build the talent base, then to engineer it, to run it, to repair it, to maintain it.
So how many people do you have now in Redwood Materials?
We have, maybe around 500 or almost 500 now, but growing very, very quickly.
So for this audience, could you just paint a verbal picture of what it looks like?
Well, I mean,
what we should imagine in our heads.
You can imagine basically coming in the front door, so to speak, of our process is, unsorted, diverse batteries, from anything from cars, old car batteries, to scooters, to
they just get
cell phones.
There.
Some come in boxes, some in barrels. It's really not very well organized.
Yeah.
I'm used to running factories that have much higher quality standards, and your incoming material is sorted and graded, and you reject it if it doesn't look just so. This is quite different. We have essentially garbage coming in on one end of the factory. It's also very low cost material, so there's a plus to this. First, we have to sort it. We sort by chemistry. We sort by size and shape. This is quite technical on how we do that even.
Is that done, again, with automation?
Automated. It's hard to be able to automate something that's so diverse and not homogeneous. Then we essentially take apart chemically these different batteries into all their different components. We have to figure out carefully how to separate anode from cathode and foils from active materials, and remove iron that might be a contamination in later process. And then all of these things end up in a process called hydrometallurgy, which is putting all these metals into a solution, and that's the starting point to remanufacture them. Because you don't really want a whole bunch of nickel sulfate solution. That's not a very valuable thing. Well, it is, but you need it in China right now, not in North America.
Right.
A key problem is that unless we go all the way to the components that a cell manufacturer can use, creating an intermediate material is something we would just have to send back to China to find a market for it.
Oh, really? So, yeah.
Creating an intermediate like nickel sulfate or something like that, unless there's a cathode manufacturer in the country of interest here, there isn't the market to take that all the way to a battery and back to a car.
Right.
So we really have to build this entire supply chain. I think so many people still kind of imagine that you put a nickel ingot into a battery factory and out comes a battery, but there's a lot of steps that go in between that, from metals all the way through to battery to car.
And is some part of this at very high temperatures?
Some parts of the cathode manufacturing are done in kilns. It's a ceramic, essentially, so it has to be baked and roasted, and yeah.
Right. And then who is your customer?
Well, the end customers are, even that's a bit of the Wild West. Directly, it would be battery manufacturing companies. So people like a Panasonic or...
Which is not far from your facility.
Panasonic has one factory very close to our first facility. But the reason I kind of hesitate is that OEMs are now very directly a customer as well. And the simple model of a supply chain where, a miner goes to a cathode maker, goes to a battery maker, goes to an OEM is all blown up.
Right.
Auto OEMs realize, appropriately so, that this is very strategic for them, and many of them are being involved all the way back at the mine. So you kind of have this, a single line which has been all kind of folded back on itself.
Right.
So we have a lot of interaction with automotive OEMs, and many of them are beginning to think strategically and realizing that they also have the same resource. They're the ones building the cars and maybe servicing them, managing the fleet. So we have direct discussions of kind of looping that back onto itself and feeding their material back into their own factories.
And have you found that the problems you've had with semiconductors has made them more aware of the supply chain issues?
Absolutely. It's a preview of, I think, a much bigger and longer constraint that could happen, will happen with batteries the way we're heading.
Right.
And almost everyone is suffering from the semiconductor shortage in their factories and their supply chain. So they have, I think, a much deeper appreciation for what happens when that a part of that gets limited, and they just have one small part that won't let them build the whole product.
Right. I suppose in this morning session, there's a morning session on copper that some of the CEOs were sitting there trying to figure out what's your cost compared to my cost, and what do you think about being cost competitive?
Well, today recycling of batteries is already cost competitive with virgin mining. We're able to do this at an incremental profit. For us, this is the cheapest source of raw materials. And not only is it the cheapest source, but it's also the lowest carbon pathway. And this is increasingly important. If we map and track back the kilograms of CO2 emitted, per kilogram of material or per kilowatt hour battery produced, there's a way lower set of net emissions if you are reprocessing versus moving it from a mine. So there's a strong incentive, both economic, just direct economic, as well as environmental,
right,
to maximize that. But I think a lot of the mining companies, it's an awkward thing to integrate. It's in some ways direct competition to a lot of the business, which is very geologic focused and optimized very well around that.
Right. So if you're cost competitive now, when you're not at scale yet, are you, or do you think?
We're ramping fast. I'd say we're at commercial scale, but this is going to be growing for the next 50 years.
So so you're cost competitive now. Where do you, at the end of the day, do you have a target which you want to be versus?
Well, part of the sort of, I'd say, bigger vision is that back to a comment you made of what is the % of raw material cost in a battery?
Right.
More than half, quite simply, and unless we can find a way to reduce that raw material cost, we're not going to keep the cost of batteries coming down.
Right.
There's a lot of talk of Moore's law of batteries, and everyone wanted to equate Moore's law to battery cost reduction, but they're fundamentally different. Right. Moore's law doesn't have a 50 to 70% raw material cost sitting under it.
Right.
It's about processing technology. So to me, recycling and reprocessing is a way to attack and change the whole equation. You change the paradigm. Because as the recycling content gets higher and higher,
right,
and because we can reprocess it cheaper than we can mine it, there's a pathway to continue reducing the cost of batteries out into the very long-term future.
Right.
So that to me is like one of the most compelling reasons to also really scale this, is that it's a way to have a steady cost down on the raw material portion of battery cost.
Right. And are you the only one doing this?
There's a few other companies starting to work in different pieces of this. I think what we're doing, as far as I've seen, is the most integrated. Yeah. And I believe it's really important to look at that whole value chain. Because as I said, if you do a piece of it, you may be exporting your material. And one of the benefits here is we can also tighten the logistics chain.
Right.
we can do these loops very close to the end markets.
Right.
So we're about the only company that I'm aware of that is doing that whole end-to-end process, all the way from, essentially from waste and from mixing that with mined material, all the way back to ready to make into a new electrode and battery.
So, and you're able to deliver a product to the battery maker, or to the automaker, that is quite far along in terms of the process that they need.
I mean, the cathode material inside of a battery is what, it's very far along in that process. It's essentially what defines the chemistry of the battery, right, the charge rate, the energy density. It really is, kind of the core material that tracks all the way to how the EV performs.
So after you've been doing this for 5 years, you've made a lot of progress. And
I wish we could be going even faster. It's amazing to me that the focus that the entire world is now putting on this and realizes how important supply chains and these critical materials are. I frankly thought we'd have more runway and more time before these problems hit the whole industry as hard as they're hitting it right now. Right.
Just a couple more questions. Are the batteries that are going into this EV versus that EV, are they different, or is it a pretty standardized product?
No, not standardized at all right now, and neither in chemistry nor in shape and size or modules. It's really all over the map. Right. So it does present a challenge, for unmanufacturing and also for the supply chain. There are some commonalities, though. Lithium-ion broadly is now pretty much the family of technologies that's scaling. Within that, you have iron phosphate, and you have high nickel chemistries of a few different flavors, and solid state is probably coming beyond that.
Right.
But they all have generally the same set of critical materials.
Right. So
get plus or minus a few different ones.
Right. So this really is, when people talk about a circular economy, this really is a circular economy.
Sometimes I think gets overused. That has become almost a buzzword in the industry, but I am confident that's how this industry will look in 50 years or 100 years.
Yeah.
We won't need to mine many new materials, once we have a fleet of cars, but we will need a vast industry to unmanufacture, reprocess, and remanufacture.
Boy, this is critical for the mining industry. It's for countries that depend upon mining, and of course it's dependent for the industry. When you talked about Tesla here 6 years ago, there were still a few challenges there. And
Just
I think, we feel very privileged to listen to you once again to see what you're doing as the next stage to make this happen. I guess the only other thing to ask is, what's the address that people should send their old cell phones to?
we have a link on our website that has the address, actually, but some of our logistics people would probably be unhappy with me. But it does work. We get a bunch of boxes every single day with nice notes and people just wanting to do the right thing. And I think it's more than just an economic reason to get a few dollars. It's almost national pride in saying, hey, these are materials we can keep in our own supply chain. It means we don't have to import it.
What you're doing is very far-reaching. I know the very next discussion is going to be about a national electric highway, which will only accelerate the need for batteries. And it's, once again, your innovative creativity is really impressive. And JB, just want to thank you for sharing this new vision of what you're making happen with all of us. So, indeed,
thank you very much.